My name is Victor Atkins. I'm with 1898 & Co. I get this question all the time, so I might as well address it. What is 1898 & Co.? We are the consultancy arm of Burns & Mac, so we're part of Burns & McDonnell. We're not a separate company. We're just a separate brand. 1898 is the year the company was founded. That's the origins of that. I like to joke it's also a brand that only engineers could come up with. I'd like to introduce my panel here for a minute, but we have been hearing a lot about the benefits of technology and adoption early. And that security and risk is kind of thrown in there. It's like, yeah, we need to worry about that, but not a lot of discussion comes out. That's what we're really going to focus on today, is the kinds of things you all should be asking and worrying about as you start to adopt technology. So I'm going to turn to my panel first to introduce themselves. Jeff Tufts, if you wouldn't mind, and then Matt, give some background about yourself.
Thanks, Victor. Thanks for I can see two people from being blinded here, but Jeff Tufts with Cisco. I lead Cisco's industry solutions for utilities globally, with emphasis on security.
I'm Matt Wakefield. I'm the Director of Information, Communication, and Cybersecurity at EPRI, Electric Power Research Institute. My role involves a lot of the digital transformation aspects. What's the data we need? What's the value we get out of the data? What's the media, the telecommunications, how we communicate it, and then cybersecurity, how we secure it. So I'm going to be coming from an angle of a research perspective on a lot of the comments that I make. Thank you.
And again, my name is Victor Atkins. I've been here for 2 years with Burns & McDonnell, but prior to that, I spent 17 years in the U.S. government, all of which was in intelligence community and national security roles, counterterrorism, counterproliferation on the nuclear side, and then finally cyber. The last 5 years, I ran the cyber intelligence mission for the Department of Energy. So essentially, it was my team's role to provide threat intelligence at the classified, unclassified level to all the executives and to the U.S. government, all the way up to the president, about cyber threats to the power grid, which we really started to see emerging heavily around 2015, 2016 with Ukraine, and then we started seeing a lot of Russian activity, in particular in the U.S. around 2017. So my role today, well, I'm going to start here at the podium and then move off to have a discussion, is the first level set, like what are we trying to secure against? What is the concern that we should have when it comes to nation-state actors in particular? So cyber attack, let's talk about that first. What is a cyber attack? I'm not talking about espionage, like stealing data and information or IP. That is necessary, and these organizations do need to have that, but that is not the purpose for what they're really trying to get at. And it's not even misinformation, although you could understand how someone like China or Russia might want to use misinformation to amplify or shape the effects of a physical system attack. When I use the word cyber attack, how we're going to use it up here is really having a physical effect in the world, disruptive at a strategic level, like say wide area blackout, at a time of their choosing. So, and they've been gearing up, particularly China and Russia have been gearing up in our networks for over a decade. We're going to talk about China specifically here in a minute, but just know that you should assume going forward that they are already in your networks today. The idea of preventing them from getting in that's bygone era. You should assume they're already in today. Also, people think of these attacks as like information technology into the OT environment. Like, I'm going to traverse the air gap that doesn't exist, and I'll go through the internet, and I'll get into the OT and cause an effect. And that is a pathway. But when we use the word cyber threat or cyber risk in this environment, for here we are at a broadband conference, we're talking about all communication modes in and out of a system. Any inject, whether it's wireless, terrestrial, microwave, VSAT, anything that can traverse data in and out of a system for command executables, pulling information, should be considered a pathway that is a cyber risk. That can get all the way down, if you're familiar with the Purdue model of OT, all the way down to process controls, right? So that can include third-party vendors, things that you've installed, and things we've been talking about at this conference today, or the last 2 days, that need to be considered a viable pathway. And it's not just cyber. Like, if you have in your mind that there's just Chinese hackers in black hats, hammering away on computers to try to get into your network, you should also consider that this is blended with cyber or with supply chain operations, right? They can Here's an example, the attack on the Hezbollah pagers and radios that we saw a couple months ago that was all over the news. In that case, a nation-state actor was able to inject and compromise the supply chain way up in the supply chain where it was undetectable to the end user, seed those devices into the environment that they wanted to hold at risk, and then they activated via wireless communication that looked and felt exactly like it was their own people. So they spoofed essentially the command and control. And the first indicator of attack was things were blowing up in people's hands, right? So that's how you can blend, sophisticated actors can blend supply chain with cyber to cause these kind of disruptive effects. And you should be thinking, I guess the takeaway is, it's not just your CISO's problem to worry about this if it's a full system kind of vulnerability here, right? And finally, a last word about the attack surface. Anything that we talk about for view, control, or safety that's digitized or network that we use for advantages and benefits, and we've been talking a lot about those here at this conference, in my worldview, are also vulnerabilities that can be hijacked by an actor to spoof the view, take over the control, and eliminate the safety features that would keep it from being overrun. In power and electricity, there's a lot of those. What used to be electromechanical relays are now digitally expressed, right? So the attack surface is expanding, and LTE is part of that ecosystem. A last word about China. Let's just talk about China for a minute, just so people can understand put some meat on the bones of this threat if you're not familiar with it. First of all, there's a book that I read even before I got ready for this conference called Wireless Wars. It's all about Huawei and China's support for that company in the wireless network. If you haven't read this book, I suggest some of you may want to. I think it gives you a really good understanding of how the Chinese government supports these efforts. It's not just a company at play, it's actually a full system there. So what is China's objectives in doing this? They want to establish control over East Asia, plain and simple. They want to establish themselves as a world power in that part of the world, and that means knocking the U.S. out of that environment. It starts with Taiwan, but it doesn't end with Taiwan. Taiwan might be the first thing that we see in that environment, but it could actually go on into the Philippines and other parts of the region. Over the last 10 years, they've reorganized their entire military doctrine to incorporate what they call systems destruction, which means they don't want to have a conflict on the battlefield or in the seas. They actually want to destroy the systems that support those systems, which is critical infrastructure in the United States. 85% of the military, active military, is in the homeland of the US. That relies on rail, transportation, communications, and all kinds of other modes that are in private hands, right? So when you hear the government talking about attacking critical infrastructure, that is the reason why China is so focused on all of these sectors. And power is the #1 target. That's the highest end of that system. Capabilities, Chris Wray, the director of FBI, has said that there's at least 50-to-1 advantage on their side for people that are focused on our system. So within the People's Liberation Army, that's around 300,000 people in the Chinese military actively focused on you. How many security people do you have in your environment? A handful, maybe? So if there's a 50-to-1 disadvantage there, you should just think about the scale and sophistication of that's what we're all up against here. And finally, just a word about timing. 2027, that's 2 years away. That is the year that Xi Jinping has challenged his military to be ready to invade Taiwan. It doesn't mean he's going to do it in that year, but he has challenged them to be ready to do it at least by then. So they have, and everything we've been seeing them do is they're on the march and will probably make that deadline in terms of joint military operations that include cyber. So, all of our plans about rolling out technology rarely consider the disruptions that would occur if there was a war in the Pacific with China to disrupt supply chains and also potentially start to attack our own systems in the process. So that you should have that in mind as we're thinking this is not an abstraction, it's actually just over the hill, right? So when you see things in the news, you should be considering that as a real thing. I'll kind of stop there. We could go on and on about this, and I invite you guys to ask questions. There's the mic over there. I really encourage people to ask questions of this panel as we go forward. It could be about the threat or some of the things we're going to talk about. But that's the end of the doom and gloom portion, right? And I'm looking at my sketch artist, I'm seeing her draw Darth Vader or something over there, so that's the end of that. What I want to turn over now, what we're going to move to is, well, what can we do about it? What are the concerns that are specific to your sector? What are the concerns that are specific to your technologies? And that's where these two guys are going to excel in the discussion here. So I'm going to move to the chair here in a minute, but I'll start with you, Jeff. Like what concerns, as we are looking at that threat and looking at the way the technology is moving, what do you think these folks should be thinking about specifically for what they're doing?
Thanks, Victor. The list of concerns, I suppose we could go on, so I'll cherry pick one here. And so give me a little bit of rope here. This will take a second to get to my point. If we think, what is our overall mission? What is our company's mission, right? So the safe, efficient, reliable delivery of power. And that's in part why we're all here in Kansas City, right? We're trying to build a system that will support the digitization of our power systems, and in many cases grid, right? And so that digitization is driving efficiency, it's driving reliability if it's FLISR or whatever the case may be. And so everything we're doing is that North Star of safe, reliable, and efficiency. And so now we embark on these projects, building private LT, whatever the case may be. But if we go back, actually, let me tie that together in the sense that as we digitize, we need to understand that the reliability of that digital infrastructure is directly correlated to the reliability of the grid. The more we become reliant on digital automation, the more we need to rely on that digital infrastructure. And so with that being sort of a foundational principle, the next piece of that is, well, what are we doing that could make that digital infrastructure as reliable as possible? So if we think back to reliability as a network architect or network designer, and we think 20 years ago where we started building, really started pervasively building private networks on the wireline side. So we had tools in our tool belt. They started very rudimentary with serial bridging to have multiple FEPs, for example. From there, we started building fiber rings, and the rings provided some level of reliability for the automation and systems. From there, we added protocols like BFD and OSPF, ECMP, and those types of things. They all became very foundational to how we architected certain infrastructures that needed to be reliable. So what I would argue, and sort of that concern is, what have we done with respect to reliability that security offers that's as foundational as things like creating fiber rings and multiple paths and things of this nature? And so what I would position here is that the security architecture needs to be just as foundational as putting rings in or multiple servers and these types of things. And so if we think of how we evolved, right? So with respect to architecture, security being foundational architecture, maybe we started with RBAC, right? Role-based authentication. That was probably our first piece into this. Then we did CIA with encryption and things like that on networks. Since then, we've added a firewall, and that's pretty much it, right? When we architect a network, that's pretty much as far as we go with just basic network architecture. And so the concern is there are a lot more pieces of the puzzle. There are more levers to pull to increase the security and subsequently the reliability of the digital infrastructure. So I think this topic is germane in the sense that we're all here to create a reliable network. As John mentioned, to have your destiny of your own network and so forth. And we need to continuously pull in the lessons learned in IT, in government, and bring it into the operational domain. So that'd be one of the basic concerns that I think we can continue to improve on.
Matt?
Sure, a comment on a couple things. One, first of all, it's very refreshing coming here. So my first one is a concern what we see in the industry is, are utilities thinking strategically? And I say it's refreshing coming here because many of you here are here because you are thinking strategically. Communications infrastructure that supports transmission, distribution to the customer, and building in and thinking about all the applications that it supports. The telecommunications is the backbone of the grid. It's becoming that from a perspective of reliability and resiliency as well. So we need to also think about strategically, are we building in the cybersecurity aspects up front? And like I said, I think many of you are here, but in my experience in dealing with utilities, they're living in a situation where they've got 20 plus legacy telecommunication systems, which are Many are proprietary. Many were designed without security built in. There's no roadmap to the future. So that, an attack on any single utility is an attack on all of us. So that creates risks for all of us. Another one is pace of change. One of the things, projects that we're working on is with smart inverters. Some of the latest IEEE 1547 standards require that the inverters that are being deployed today have built-in communication capabilities. Our lab testing that we're doing today, that even though they may be certified for a particular communication protocol or standard, we're finding they're not interoperable. And then can we get it to communicate? Yes, we can, but it's not without a lot of work or retrofitting to be able to do that. So technology being deployed today, these smart inverters, almost none are being communicated with today. However, we're expecting nearly all of them to be communicating in the next 10 years. If it's not just for grid enhancements, but it's possible for the reliability of the grid. And it's going to be very expensive to retrofit those. So we need to get ahead of that. So that's very concerning. Are you looking at the communication capabilities? Are you demanding that your vendors are interoperability? And not only can they communicate, but is cybersecurity built in? And thank you for scaring us with all the stories.
I have more where that came from.
Yeah, and so we need to think beyond just traditional approaches and perimeter defenses. We must be thinking and assuming that the adversaries are in our systems today. And that's a scary thought, but it's a reality, unfortunately. That attack surface area is expansive. It's growing, it's very complicated. So there's approaches that we can take to mitigate those risks. But also, as we think about LTE, and depending on how it's architected, if you are driving towards all the benefits of an LTE network or 5G or whatever it may be, you're most likely eliminating other networks. You may have a centralized core. This becomes an attractive target that you must architect it to have backups and failovers and things of that nature. So just another perspective to think of. So one other thing, another scarier thing that concerns me is insider threat. We're seeing this evolution of more and more technology. So from an insider threat, not only utility staff, but one that scares me even more is with third-party aggregators. When you're dealing with a third-party aggregator that has access to hundreds of different types of solutions, whether it's multiple EV manufacturers, multiple thermostats, multiple HVAC systems, whatever it may be, then you're depending on a vendor that can control potentially hundreds of megawatts of load or resources that you have no control of. You have a contractual relationship with them. If an insider attack is in there, that's one of the things that concerns me. So in summary, are you thinking strategically? And I think many of you are, because that's why you're here. Is your leadership thinking strategically? Because you've got to convince them. These are big investments. And it's important to understand the benefits, but also the risks associated with that. And then the retrofitting after the fact has impacts from a resiliency perspective, from a business perspective, and a cybersecurity perspective.
Victor, I just wanted to comment or underscore something, Matt, that you just said, and that is very specifically the packet core, right, since that's in part why we're here. So for the folks that have been working on networks like this that went through the wireline progression, private wireline progression, and now we're in the wireless progression, we had distributed control or distributed control plane, and that's different. And so the natural inclination is to architect something today like you architected the last one. And so before we used to have routing protocols sitting on routers and so forth, and now we have a centralized packet core. And if you took a look at what a national provider does to protect from a cyber or InfoSec standpoint, their core, knowing again that cybersecurity is foundational to the reliability of that service, they understand that if that gets breached, there's a service degradation piece. So that would be another take-home, I suppose, concern. An area that we can always improve is to recognize that architecturally we have a centralized control architecture versus what we used to have when we redid the wireline piece of it.
Yeah, I think just to amplify or add a little piece here, For as long as I've been in cyber security or cyber risk consulting and management or even intelligence, I've always heard people say, man, I wish we'd have thought about cyber sooner. You know, like we built this whole system decades ago and we didn't think about it. And yet now here we are, particularly in your environment with private LTE and pushing things to the edge and all this technology is coming in. We are at the precise moment right now to do that today, to build systems that could withstand and sustain themselves in this new threat environment that is not going to go away. And so a concern I have is that we just don't learn that lesson, that we just make the same mistake and continue to act like cybersecurity is something that comes later, potentially by a third-party vendor who comes in after everything is built and then tries to secure it after, you know, it's almost unknown what the risks are at that point. So a concern I have is just like making sure that we are on top of this, which leads to risk mitigation, right? Like what now with those concerns in mind and what, you know, we're not helpless in the face of this. This is one thing that I don't want anybody to ever take away. We're not helpless. Defense in this space is actually achievable. You just have to plan for it. So I'll start with you, Matt. What kind of strategies or considerations from a risk reduction perspective should people in this room go home and start asking their organizations about?
Yeah, I think the cybersecurity community is pretty well informed on a lot of these approaches. There's cyber-informed engineering approach that you can take, and it's a risk-based approach. This is looking at what is the likelihood of an exploit compared to the consequence of an exploit, and then using a systems engineered approach to look at what are the controls you need to put in place to mitigate or reduce the risks of those. So it becomes pretty complicated from a systems perspective. We're finding that we're using this today more on evaluating systems that have been deployed 10 or 20 years ago. You may have heard about the 4 or 5 years ago, the Chinese transformer that was purchased by a US utility that had risks of having backdoor vulnerabilities built into it. So we did an assessment. You know, a transformer is an attractive target, especially a transmission level target when they're very, they can do a lot of damage in taking out infrastructure. They're very costly. There is not a lot of spares. So when you look at what are the assets that they're targeting, it's things like that that are going to have a big impact. So taking a systems engineering approach to look at that from a combination of perspectives at the component level, combined with the subsystem level and the overall system level, and looking at from a telecommunication perspective, it's not just the telecommunications network. I gave the example of smart inverters, but even, you know, be thinking, are you putting communications on your larger transformers? Is that creating risks? How can you mitigate that? Another thing, I think a promising thing, is the 3GPP standards that are available. They have a lot of cybersecurity capabilities in them today or are being developed. As we look at those standards, we're seeing many of the commercial carriers don't have the same security requirements as critical infrastructure. So they may not be taking advantage of those. So I think it's important for us to understand, to look at what are those capabilities for LTE and 5G that we can implement to protect critical infrastructure. Things like zero trust, looking at network slicing, microsegmentation, geofencing. Some of those capabilities are built in today. We need to understand the use cases, when to apply them, the costs associated with that, and having scientific results that measure the performance and benefits of those. So those are a couple of thoughts.
Jeff?
Yeah, this will be easy. I just agree. So I think that is the answer to this question, is how do you mitigate? Is you have a risk-based architectural approach. So a tangible way to express that is, I understand that the packet core has more downstream negative effects if it has a service interruption than a eNode B. And so subsequently my architecture has to be more stout or more resilient in that area. So that is by far the gold standard of how to approach this. And to your first point, it should be during the beginning process of the architectural scheme. But to give you, since you've already answered the question, what I would argue perfectly, I'll give you just a couple anecdotes of sort of how to mitigate risk and so forth. So I think foundationally is, to understand the business impact of what you're doing, which is essentially breaking it down with your approach. And so I'll give you an example that I think is pretty tangible. And that is to understand if something goes away, what is your downstream effects? And so we've done a number of pen testing and research and assisted clients in this space and so forth to understand how do we remediate a risk that happens in IT and isolate OT. So that's a pretty common ask from critical infrastructure, since most of the vulnerability is in IT, or at least the beginning part of vulnerability is in IT, such that if something's happening over there, I want to firewall everything off and so forth. So risk mitigation strategy would first understand how to do that. And what's always interesting is what breaks when you attempt to do that. So that would be, very tactical. What could I do? What could I bring home? Is if I need to sever the industrial DMZ, I need to understand what breaks, what business processes break. It's informed, of course, with the Colonial Pipeline attack, but I've seen it happen at utilities where, we'll go through the exercise and we'll segment IT from OT by just creating a deny rule in the industrial DMZ, but access control is in IT. And so now we can't badge into any substations. And so, through the red team exercises, it's bolt cutters, right? So that starts to inform us to understand all the applications that the business needs to continue for operations, and say, do we need, architecturally, do we put this into the industrial DMZ such that IT can go completely away, but operations can persist? And so that has been a lot of work that's gone on over the past couple of years in response to the Colonial Pipeline. The other tactical thing I'll say is, as we build private LT, almost every utility I know has some type of cyber incident response or incident retainer with companies like Cisco and others. In most cases, the team that will be on the hook to respond does not often, they're an enterprise team often, and so they won't necessarily be experts in LTE, packet core, eNode B. So if you have incident response retainers and those types of things, make sure that team gets read into what you're building or about to build, so they're not figuring it out during an exercise where you're being graded, or worse, an actual event.
I think I'll just add a couple things here, just because, particularly on cyber-informed engineering. It's for those of you who don't know what that is, it's a methodology that was developed by the national laboratories. When I was at Department of Energy, we put a lot of information into that, particularly around helping them understand the threats that they should be looking to mitigate. And what it really starts with is an understanding of high consequence events, which in other words, it takes an evaluation, and we do this now at 1898, is consulting to help build strategies to prioritize security efforts, because you can't secure everything. And if you try to secure everything equally, you're going to fail. So what should you do? You have to start around the most important processes or critical functions within your environment that are critical to your business, whether that's delivering power or making a widget. And some people have opinions on that. The engineers may say this thing is more important than anything else in my facility, or the IT people may say this in technology we put all this money into is most important because it cost us so much, or whatever. It's really a organization-wide assessment to understand what is the most important thing that if you lost it would hurt the most, would have the greatest impact. That's the consequence piece of that. And then you focus in on what your cyber dependencies and risks are around that. Because we're not talking about risk elimination in most cases. You're going to have digital assets, and you're going to have to incorporate this technology, which is going to add risk. We're really talking about reducing the risks, and reducing the risk most around the things that hurt you the most. And it is a methodology and its approach, and it does take a systems engineering approach. It's not just looking at technical CVEs around an IT asset. It's looking at the vulnerable pathways and features, some of which you may not need to operate your business, but they just happen to be there because a vendor sold it to you, or it's just part of the technology. So being really purposeful about the things you need, and then having a defensible architecture around that does reduce risk significantly. And I can tell you from the position of an offensive cyber actor, that's a hard thing to overcome. And so it actually makes this effort that China and Russia and others are trying to do so much harder to achieve if you take the steps of hardening the things that they're after. Because one thing I will tell you, when Chris Ray and others talk about the Chinese intelligence and military approach towards your networks, again, it's not just hackers, it's an all-intelligence approach. And I believe, I just take my word for it, given my background, in many cases, the Chinese know more about your networks than you do, because they've been enumerating and understanding them for a decade or more in some cases. And so if they know that much better, your first step is also to understand your system better and then do a better job of hardening and focusing on that. And then the last piece is on incident response. I mean, we deal with a lot of incident responders that are like technical responders or at a site or a plant. And it's just, well, I have an IR plan that's just around this process. And I would recommend that when we're talking about these high consequence events that could be, Colonial Pipeline is a great example. Colonial Pipeline reputationally is now associated with failure to deal with a cyber event. It's a bad reputational risk. It's a cost that they incurred. That's a business issue. That's not a technical issue. So when you're looking at risk to your organization, it's really, and you're talking about consequences, you need to have the executives and the people who are like people you don't think about, strategic communicators, the executives, the financial people, the people who have your relationship with your local FBI office. Like all of these people need to be involved in your incident response plan and then exercise it. Because you do not, trust me, you do not want to be in a crisis trying to figure out where your backups are, or if the guy or the woman who's responsible for that even knows that they're supposed to be on a 24-hour string, and do you even have their cell phone? Right. So like these are the kind of things that you tease out through exercises, and then you get more confident, and you can get the muscle memory built when you actually need to have it. And it's not that significant of an investment to do things like that, to be honest. Okay, another question here. So we talked about what we think people should do, right? What are people actually doing? What are some positive trends in terms of tools, techniques, strategies that people are implementing in their networks today that are reducing these risks that you want to highlight and that they should do more of? Start with you, Jeff.
Great. I'll just cherry pick 3 here real quick. So if I look at trends, certainly one, we're in the meaty part of the standard bell curve of adoption, and that is correlating business impact with cyber risk, right? And part of that is with NERC, and part of it is as SIMs like Splunk and so forth are able to understand, okay, this transformer is larger than another transformer, so it needs to be protected. So that's, without a doubt, that's a trend, and it's a positive move forward. The other one I'll mention is, in general, ICS, so in industrial controls security, right? So the vendor community is maturing, the client base is maturing in terms of adoption, and so essentially what that is taking all the posture, the InfoSec postures we've been using in IT, and migrating them to the extent that we can into operations. And so what that means is in some cases, very standard solutions like flow-based monitoring. In other cases, it's east-west lateral movement and understanding of industrial protocols. So being able to understand or have visibility. I think you opened your remarks with, it used to be boundary-based security vis-a-vis VLANs and firewalls. It's very much the trend now to understand, appreciate, and attempt to deploy in large scale visibility mechanisms to monitor east-west traffic, for example, within a sub or from feeder, along a feeder on a private LTE network, and to be able to do that with the understanding that someone has already breached the network. So I would say that's a pretty significant trend that I've seen. I'm not sure if you want to add to that.
Just building on that, I think the overall situational awareness and visibility is improving. We're seeing a lot more capability to and investment to understand what's going on in the network. So with the kind of the premise that assume they're in, people are taking that seriously. And I would just like to expand. I think that the capabilities of LTE to gain that visibility are huge compared to traditional telecommunications network. So that's a very powerful thing. It's a little maybe forward-looking to gain that, but we're seeing some things at Evergy and some of the things, Southern Company and Ameren that are doing that. So just to build on that.
Yeah, and I was remiss. I had 3 points, but I I honestly spaced the third. So the other
It's
trend.
the lights.
Yeah.
The lights are like that's.
I
But
think-
we're getting tan.
I should have went with SPF 90 up here. So the other trend, and we saw it in the Plug Fest, and that is the notion of distributed applications. You know, we saw it a little bit with the NVIDIA talk, and that's a little bit more forward thinking and forward adopting. But we saw it with you know, Dan Mady, who was up before, getting an award, and in Eaton, and doing something that's very much able to do now, has fantastic value for voltage reduction, which we all know is there's a great business case around that. But how do we secure that, right? How do we manage? Are we really going to put this application in 22,000 routers on pole tops, right? And so, you know, obviously there's an operational challenge, just deploying version management and those types of things that Dan would talk about. But there is, how do you do security on an application when it's a router first, and now it's essentially a data center on a pole. And so trying to understand the risk that we're taking versus the benefit we get out of that, instead of, you know, 15-minute control for voltage reads, we're getting down to, you know, 30 seconds or whatever it is that Dan and Eaton came up with.
Yeah, I think two things that I've seen that I would like to see more of is first, it's usually called like IT/OT convergence. There's buzz names around it, but it's organizations that are recognizing that the engineers and the operators and the people who really manage and execute and maintain and operate the control systems need to be put in the rooms with the cybersecurity people usually on the IT side, who are trained in IT but not in OT, to really sit down and talk about how you're going to protect this facility, or we're going to integrate this new design, or we're going to integrate this new technology. How are we going to secure and reduce risk that together, as opposed to what I think is kind of typical or traditional maybe, which is just, oh, it's a security question, give it to the IT side of the house. And they may not have any understanding truly about the operations at the other end of that they're trying to secure, which leads to all kinds of badness. And so just having more organizational collaboration, not org charts and things like that, but more like building processes that are informed and collaborative, and starting to have everybody see the value of those processes, I think is a trend that needs to continue. And, you know, we had a panel up here earlier about operators and technology integrating, but it was, I think, the CTO who led the fight on that. So who would be responsible when we're talking about integrating LTE and network control? Who would be responsible for securing that in your organization? I mean, I don't know that there's always the right answer, but you've got to find those people and put them into those discussions together. And then the other thing is, you know, my job here at 1898 is to advise executives and other people about how to like reduce their risk, or improve their security around, and we try to strategize and build roadmaps. So it's a consulting practice genuinely. But I also work for a large AEC engineering company, and they adhere to existing standards of care that build things to proven standards and proven designs. None of what we're talking about here when we're talking about cybersecurity and cyber-informed engineering exists in any current standard. So if you're just asking an AEC to build a system, they're not necessarily going to put these principles and concepts in unless the asset owner asks for it, right? So if you're an asset owner in this room and you're wondering how you could help, the first thing you should be doing is, how do I make the security and risk questions a requirement of a new system? If you ask for it, firms like Burns & Mac will build it for you. But you can't expect them to just build it for you, or that these things will come out into commissioning as if it's going to be all secure. You've got to ask for it, and you've got to demand it. So that's more of a customer side behavior that I think needs to continue and be more prevalent in the market. All right, we have, I think, 1 minute or 1.5 minutes left here. So I hope some people are lining up for questions. Nobody, which is pathetic. Truly pathetic, everybody. I just want to let you know. Okay. All right, somebody's coming up. Name and shame. It's how I was raised. So just takeaways. Let's just go to takeaways. Like, if you guys we've droned on here for a while. Jeff, what is one takeaway you think you want these folks to come away from, remember from this?
Yeah, it's simple. We're here to build something reliable for a reason, and security is a foundational tenet of the reliability that we're trying to build. And so bring it in early, I think, is your point.
Yep. Matt?
EPRI, collaboration. We've got a recent Department of Energy project with a Southern company, Virginia Tech, George Mason University, and Anterix to architect an LTE and 5G cybersecurity approach for critical infrastructure with a cost-benefit analysis tool set. So hoping to engage UBBA in that as well. And I'll just end with our tagline, together shaping the future of energy.
I think my thing is people like stories, right? You guys like stories. I'll tell you a story. When I was a kid, I grew up in a place and time when little kids solved their problems on the playground by fist fighting and the teachers would watch. Doesn't that sound terrible? I mean, you would never tolerate that today, right? And I went to my brother, older brother, and I said, how do I even know how to deal with this? What do I do? And he told me, he said, the first thing and only thing you really need to know about about fighting is to know first that you're in one, right? You don't want to be standing around and waiting to get a haymaker land on you because you're not anticipating it. And I think if you learned anything from all of this is that we're in a fight. We've been treating the market with China as a trade war or a economic issue, but I would tell you they've been preparing for war. This is about power. It's not about money. And so you all in this sector, like it or not, Leslie Duke stood up here and said your mission for 100 years has been affordable, reliable power for your customers. And I would add to that, and now whether we like it or not, you have a national security role too. And I would just encourage everybody in here, no matter where you are in the system, no matter what your role or responsibility, that you embrace that. And that you try to take that mentality to your company, to your organizations, and ask the questions about risk, ask the questions about how this new technology might harm us, and just get the conversation going. Because that will have a greater impact on operational resilience and pushing back on this than anything else that anybody from the US government can do. And that's why I came to Burn Back, because I left the government because I realized that the industry is the answer. You are the answer. And so I hope that you guys take that on.
We got two guys here in the line for questions.
We have 2 questions and we have a break coming. So we're eating into that. So go ahead.
So my name is Rex Lee with Space Data, and I'm also a security advisor. I specialize in endpoint cybersecurity, anything supported by the Android OS, Apple iOS, and Microsoft Windows 8, 10, and 11 OS. And what I haven't really heard y'all address is endpoint cybersecurity. Most cyber attacks today are not coming through hackers trying to breach the firewall, but they're coming through popular apps, and also they're being embedded through the supply chain in the OS of the endpoint devices supported by the network. One example is a Rahib refinery oil attack in 2018. The Windows 10 operating system was compromised, and the attack was done through that as the devices came through the supply chain and then were added to the network and provisioned on the network. And that's where a lot of these cybersecurity attacks are coming from. And regarding the operating systems, the Android OS, Apple iOS, and Microsoft Windows 8, 10, 11 OS, they're supported by surveillance and data mining technology rooted in surveillance capitalism, so they're unsecure operating systems to begin with, because apps today are like legal malware. Recently, regarding Israel and Hamas war, the Red Alert app was compromised by Sudan Anonymous, a hacktivist group, and Google actually had to remove those apps from the Google App Store, and so did Microsoft. So regarding endpoint cybersecurity, what are people doing to mitigate these risks that are starting to come up through the operating system and the apps?
I'm probably more the endpoint person up here, so I can take a stab at that. So behind the curtain here, that was our 4th question we didn't get to, so that's why you didn't hear a lot about it. But let me try to take your point a little bit more broadly. So with those operating systems predominantly, there are many protection schemes that are used in the IT environment to monitor, and that goes to my point about visibility. right? So the notion of being able to have visibility into the kernel of a device, the applications that are running on the device, looking at flow-based data to see if there's DNS queries, all these things exist within the vendor community on the IT side. And so that's a well-understood scheme, it's a well-understood architecture, the pieces and puzzles, they continue to be innovated by Cisco's and others. When you get into the ICS side, into the industrial control side, there's at least two parts of it. There's many others, but there's NERC-CIP, I think it's 7, which is supply chain. So that's somewhat in response to the first Ukraine attack where firmware was loaded onto the serial to IP converters, right? So understanding things like the just rudimentary supply chain, understanding the notion of signed firmware, those types of things. But then you get into the network piece, which is the routing piece. And so that's where you had mentioned zero trust. You can't do zero trust on 48,000 pole tops. And so you have to have some level of value engineering because you can't do everything. And you have to have graduations of trust, fully trusted, less trusted, and so forth. And so being able to do endpoint security, you're really within the domain of private LT, you're largely relying on the vendor community of the UE and the power systems endpoint supply chain and manufacturing piece of it. There's much more to that, but that's the first blush that I would take to your question.
So I'm getting screamed at, which is fun. But you guys have a break, and I want to encourage all of you, first of all, give a hand to our panelists here. And also, see us at the break, see us at the event, see us around the conference, ask us questions, and we're really happy to answer it. So thanks again for your time.